Welcome to SPC versus DOE. This video explores approaches for reducing variation in processes. Process improvement faces hidden challenges. Conventional wisdom suggests that unsatisfactory outcomes require costly re-engineering with new materials, equipment, or technology. Organizations often alternate between neglect when things work and panic when problems arise. Experimental studies can be incomplete because they only examine selected factors, ignoring other relationships. Optimizing a process is impossible while assignable causes remain unidentified, causing erratic changes. Trying to improve a process without checking for assignable causes is like playing with less than a full deck. Process behavior charts are the only path to operating at full potential, as they help identify sources of exceptional variation. Design of experiments, or DOE, has its limitations. Research and development teams often prioritize which factors to study, as investigating all suspected causes can exceed time and budget constraints. Experiments answer specific questions and confirm relationships under controlled conditions, but they inevitably ignore some relationships. For example, factors the 14th and the 16th of may not be studied, yet still influence the process. As a result, excess variation can appear from unexamined factors, and what we learn from experiments may be incomplete, missing dominant factors not included in the study design. Sometimes, production diverges from prediction. Research and development may provide accurate information about certain factors, such as 5, 1, and 7, and their effects on process characteristics. However, production using these factors can experience much more variation than expected, resulting in excessive scrap. Introducing factor 4 as a control may have little impact on reducing variation. The excess variation often comes from factors like 13, 14, and 16, which were not studied. Re-engineering involves introducing new technology, equipment, procedures, or materials. Experimental studies help identify control factors and optimal levels. Observational studies, such as SPC, allow listening to the process with all cause and effect relationships present. To reach full potential, assignable causes must be removed to achieve minimum variance. SPC completes what DOE starts by examining all factor impacts in real operations. Observational studies finish the job begun by research and development, bringing new processes to full potential. Starting investigations with observational study prevents optimizing while missing critical information. Let's compare SPC and DOE. SPC reveals unknown causes by examining all factors during routine operations. It works with observational data generated continuously, allowing sequential detection of emerging problems. SPC requires no assumptions about probability distributions and provides the only path to full potential by removing exceptional variation. DOE efficiently tests specific hypotheses about selected factors under controlled conditions, determines optimal levels for control factors, and provides rigorous statistical inference about studied factors. However, DOE must be complemented by SPC to address factors not included that still affect outcomes. Always begin by checking existing processes for assignable causes using process behavior charts. Remove assignable causes before re-engineering to establish baseline performance capability. Use DOE strategically when re-engineering or optimizing control factors on predictable processes. Continue SPC on new processes to bring them to full potential operation. Start investigations with observational study to avoid optimizing while missing critical information. If operating at full potential but not meeting requirements, then re-engineer and continue charts on the new process. Learn to maximize the current process before expecting to maximize a new one. Operating at full potential is key for meeting requirements economically, rather than through expensive re-engineering.